Welcome back. Here in section 2, we're going to be talking about the standard form of a quadratic. Now, standard form is different than what we've been doing in the first section. And this is actually what you guys discussed back in exponential algebra when I learned how to graph quadratics back then. So, standard form of a quadratic is that usual ax squared plus bx plus c that again you guys learned 2 years ago in Expo. Okay, so let's go back and let's revisit this idea of how to graph this and all of the pieces. All right, so first thing is we need to remember, well, how do we find what A, B, and C are? Well, A, B, and C come from what are the coefficients of the x squared, x, and the constant. So in this one, A would be 1, B would be 2, C would be -3. Okay. And then remember, you have this formula. Now this is something you're going to have to memorize. So I definitely recommend highlighting it, putting a star by it, something, because this is something you're going to need in order to do any of the vertex calculations. Okay, so the vertex, the x side of the vertex is going to be at -b, so -2 over 2 times a. And in this case, a is 1. So that's why you need to know how to find a, b, and c, because those are used in that little vertex formula. Okay, so -2 over 2. So my vertex, the x value of my vertex is at -1. Okay. So how do I find the y value of the vertex? Well, the y value of the vertex comes from plugging in that value that you just found back into the original function. So the original function was x squared plus 2x minus 3. So all you really have to do is plug in that -1 into the original function. -1 squared is going to be 1. 2 times -1 is -2. Then minus 3. So 1 minus 2 is -1. Minus 3 more. So here my vertex is living at -1, -4. So I'm going to plot that point. Okay. Now that I have that point, the next thing I want to identify is the axis of symmetry. Remember, the axis of symmetry is that vertical line that goes through the x value of the vertex. Okay? So here is that x equals -1, is that vertical line, and you do always need to show it. Okay? Now, this one, the next step is finding the y-intercept. Okay? So remember, y-intercept is when x is 0, okay? So just for a moment, I want you to picture plugging 0 into this equation. Well, if you plug 0 into this equation, that drops off, all that's left is the c value, okay? And in fact, that is always true, okay? The y-intercept of any standard form quadratic is always that c term. So I get that point right there. All right, so I'm getting closer. Now, when we're graphing them in standard form, now instead of moving this thing around, well, we already have where the vertex lies. So all we need is another point to help us. And this is where we're going to use the property of the axis of symmetry. Because axis of symmetry can reflect points across it, okay? So for example, this y-intercept is sitting 1 away from my axis of symmetry. That means there has to be an identical point on the other side. That's what it means to be the axis of symmetry. It has to have the same thing on both sides of it. Once we recognize that, now I can actually finish drawing my shape. Now I can draw my parabola. Okay, so again, still not that bad. It's just a different technique that we have to remember in order to graph this. And then, just like before, we do have those additional pieces we're going to want to find. So for example, my vertex is the bottom of my graph. Okay, so because it's the bottom of my graph, it's the minimum value, and the minimum value is -4. Remember, we take the y value of the vertex. The domain. The domain is all real numbers, or again, you can use that fancy R. And the range is going to use that minimum value from the vertex. Okay, and where are all of my y values? Well, all my y values are above it. So greater than or equal to that -4. So all of those pieces are identical to what you did before. So you don't have to worry about that. It's mainly just the subtle differences in how we're going to graph these things that you need to be watching for. So let's get some more practice in. So first thing, the vertex. Well, so here my A is 2, B is -8, C is 1. So my x value of the vertex, -b. So b is already -8. Negative b is going to be +8 over 2 times a. So 8 over 4 is going to give me 2. And now, of course, to find the y value of the vertex, I need to plug that in to my original function. So 2 squared is 4 times another 2 gives me 8. 8 times 2 is -16 plus 1. So 8 minus 16 is a -8 plus 1 gives me a -7. So I plot my vertex and the axis of symmetry. Axis of symmetry is the vertical line that goes through that point. So x equals the x value of the vertex. And now I need to finish graphing this. Well, remember, the next point that we're interested in is the y-intercept. Okay, and the y-intercept is always 0, then whatever that c value is. So that's always the next thing that I want to plot. Find me the y-intercept. Even though it's not on the list of things, you still need to find it. And now I'm going to mirror it across. Okay, so it's 2 away from my axis of symmetry. So I'm going to make a point 2 away on the other side. Okay, I mirror it across at axis of symmetry. And now I connect my points, making my curve. Okay, make sure that it is always curved. If you make this line straight, ugh, then that looks like an absolute value, and that's not what I'm looking for. Okay, so do be very careful that you are getting a curved nature to your graph. Okay. Then, of course, looking at that oh so special vertex, it is the bottom of our graph, so that makes it a minimum. And its value is that y value of the vertex, okay? That lowest value. Domain, all real numbers, or again, ARN, either one. And range. I'm looking at my y values. I take the y value from the vertex, and my graph is going up. So my y values are all greater than or equal to that -7. All right, so again, once you get good at it, again, not too hard. It's just making sure you know those small calculations and that process. So let's do another one. So here, my A is -1, B is 4, C is 3. So again, to begin the graphing process, you do have to make sure you know that formula. -b over 2 times A. So 4 over -2 is going to have an x value of -2. And now I need to find the y value. So now I'm going to plug in that -2 into my function. So -2 squared is a +4, but then I still have that negative out front, so it goes back to being a -4. Oh, I'm sorry. I did that wrong. I apologize. Hopefully you guys were questioning what I was doing because I forgot -b would actually be -4 over 2 times -1. So again, I apologize for that, but I'm hoping that you guys thought what I was doing was a little bit strange, okay? I hope you were picking up on that as I was doing it. Now, let's plug that in. All right, so 2 squared is 4, but then that negative out front is going to switch it to -4 plus 8 plus 3. So 4 plus 3 is going to give me 7. So there is my vertex. And then, of course, it axis of symmetry lives right there, going through the x value of the vertex. Now, you do have to remember, even though it's not mentioned, you do need to take that 3 and make that your y-intercept, okay? That is completely necessary in order to finish this graphing, right? And then you can see your y-intercept is 2 away from your axis of symmetry. So I'm going to reflect it over and make a point 2 away on the other side. Remember, that's what it means to be the axis of symmetry. Then, of course, draw my graph, just like that. This time, that point is the top of my graph, which is making it the maximum point up at 7. Domain, we love domain because it is always all real numbers for quadratics. We can use any x value we want. In terms of y values, the y values go up to 7, but they're going downward this time. So it's going to be everything less than or equal to that 7. And now I want to take the time to show you something really, really cool. Okay, I want to show you on the calculator that your calculator can actually graph these for you. Okay, now again, I know this isn't shocking to you. I've shown you graphing before. However, I just want to make sure that you're familiar with its capabilities for these. So graphing is always y equals, and then you can actually type in x squared plus 2x minus 3, and it'll actually very nicely graph that for you. Now, obviously, you need to know how to do this by hand still, okay? I need to see that work. But this is a really powerful way for you to check your answers, okay? And then you can even go into the table menu, so second table, and you can look at the points that you're plotting to make sure that the points that you have make sense in the context of your graph. Okay, so again, super cool that you can do this on the calculator, and then you can use your table to make sure that you have the right points that you're plotting. So that's super, super awesome. And you can even graph something in vertex form as well. parenthesis x minus 4 and parenthesis squared plus 1. It can even graph something in that form for you as well. Okay, so this is a really, really great way to help you check your work. Okay, after you've made your graph, check it on the calculator to make sure that it looks the same. If it doesn't, go back and fix your work, please. Okay, but again, just a really, really cool thing to help you make sure that you're doing all of the right work and to give you as many technology resources as possible. So thank you so much for joining me for this. Make sure you have all these notes filled out and come back ready to do your practice work.